in the holder, the IPG holder, and the switch box is switched over to co-robot. Will that allow the Fanuc then to take control of the LightWELD system? It's a full control. You can the functions that you could do. You can recall any IPG preset. You can call any user preset. You can change the power. You can change the wobble width. You can change the wobble frequency. You can set and you can also set the wire speed. We're supplying all these units. With the Fanuc has a special board that they supply that allows you to control the wire feed speed. So people out there that have existing IPG light welders, we are able to control the wire speed on the existing wire feeders that you do have. So I'm going to turn this over to Brennan. He's going to give you a little rundown on the CRX and the development, and we'll go from there.
Awesome. Sounds good. Hey, thanks, Glenn. So for those of you guys that aren't familiar, my name is Brennan Palmer. I'm a district accounts manager for the material joining group at Fanuc America. I've had the opportunity here to work these last several months with Serra Laser in developing this product. This has been a lot of fun. It's been really cool. The CRX product has been a phenomenal product with a icon-driven timeline of creating programs. And what Serra Laser has developed to make those icons work has helped it really streamline. Let me back up a second. So the CRX 25, the one that we're zooming in right now on, that is the largest collaborative robot in the industry.
David.
That robot stands at 1,889 millimeters of reach, roughly 74 inches. So tying the two together gives us a lot of capability, even onto larger NEMA enclosures or whatever the weldment is. Right. Fanuc's CRX robot also comes with its 40 years of proven reliability and dependability that customers expect from the name Fanuc. Awesome. I'm sorry, I'm watching Evan move around the robot. So if you can't see, it is a big robot. A lot of fun. This still uses our Samsung 10-inch LCD screen with the new tablet user interface of dragging and dropping icons to create simple to use programs. Right. Whereas at the same point, you can use a traditional teach pendant to program if your operators are already familiar with Fanuc's legacy type of teach pendant programming. Give you that versatility. So great for first-time robot users, as well as those folks that already have a host of robotic products.
And Brennan, what about programming offline?
Yeah, absolutely. Great question. So we do have a whole host of offline programming products. So like the Fanuc's Robo Guide is really the parent offline programming. We have Weld Pro, which allows operators to create those programs in a virtual world. There's some neat things, and I won't get too down into the details, but we've got some great tricks and tools to be able to take your virtual environment and transfer it to reality.
And I think one of the reasons, or it seems to me like one of the reasons that Fanuc was picked was because of your past development work with people like Lincoln, and is that correct?
That's right. Yeah. We've really done a great job to try to build up our brand and reputation to make a very reliable product. Our collaborative robots are IP67 rated. They're meant to work in these dusty, dirty environments, right? As they sit, they're industrial robots. Even though they might look nice, clean, I've even been told that our robots look like they belong in a medical facility and not a job shop. They are built for our industry. They're built to be welding. They're built to be in a dirty environment and handle it. That decision, people have chose to collaborate with us to build out a variety of products to go with these robots, and it has to do a lot with the reliability. We stand behind our product. It's an 8-year zero maintenance on the motors and the body of the robot, so it has that reliability proven into it.
Hey, Evan, you ready to demonstrate it?
Sure. Yeah, you guys can all hear me okay?
Yeah, I think so.
Okay. Yeah, so what I've done is I've gone ahead and, sorry, I know this post is kind of in the way of the camera, but I've gone ahead and laser cut and then bent these channels. And I have pre-tack welded them just by hand into a square tube format. So just to show you what we're working with. So I'll take one of those tubes here and I'm gonna put it on my my table. I have some clamps here to keep the positioning accurate. And I'm gonna go ahead and run this program. So what this program is gonna do is I'm gonna do a high-speed weld down the center of the tube, combining them together, followed by a cleaning pass. Then there'll be a pause in the program. I'll flip the part. It's gonna then go ahead and do the same thing on the other side, and then also do a zigzag type spot weld through this third piece onto the top here. So
Hello?
let me go ahead and,
Is Henry there?
can you hear me?
Yeah,
Okay.
Okay.
So let me
all
go
right,
ahead
thank
and run this program. It's all fixed up and ready to go. So I'm gonna take the tablet here. I'm gonna make sure
Adrian,
that
¿dónde
I
está?
am at the beginning of my program and I'm gonna click start.
you. Ok. No, ¿puede decir que me habla? Ok, gracias.
There we go. So as we speak, this program is going to follow the instructions that I programmed it to do, and it's also able to call up the welding parameters in the LightWELD and change the program as needed. So we have 3 different programs being called up in this. The first of which is going to be a continuous wave laser weld. The second one is going to be a cleaning function, which is going to remove the discoloration off the surface and clean the metal. And then the third one is going to be the zigzag spot weld, where it's going to create a linear weld through 2 pieces of metal.
and his welding speed on this is about 100 inches per minute, and his cleaning speed is about 200 inches a minute.
So now I have completed this side. I'm going to flip it over here.
And for people with light welders out there, if you look as this goes through here, you can see that it's going to change
Hello?
the cutting conditions.
Hello?
of a light welder.
Yeah, te voy a avisar, jeśli te Zoom pom, te steroty. Ok, all right.
Hey, it's coming for you.
Yeah. Luckily, it would stop if it did run into me, being a
Yeah.
collaborative robot. Just making sure everything's fixtured good. So it's doing that same weld this time. Gonna go through and do the cleaning pass, and then it's going to attach that other plate that I put on there. So what I'll do after this completes is I'll take this part out and I'll bring it a little closer to the camera so I can show you guys. I know it might not be the most ideal looking at it on that from this angle. Let me grab this other part. David, if you want to zoom in on this guy here. Can you zoom that far? Okay. This side? All right. Is that all the way zoomed in? Okay, so what you can see here right on in the middle, let's see, right here is the seam weld that was done at 100 inches a minute. This weld is full penetration into this stainless tube here. Hopefully you can see that. So 100 inches a minute weld speed. And then we've gone over with the cleaning pass to remove the discoloration. You can see that nice shiny strip in the middle, as there was a little bit of discoloration after doing that weld. So that's the same on this other side here. And then what we've done here on this one, I'm not sure how you can make it out in the camera, but you might see a little zigzag effect on this thinner plate. And that is a what I call a zigzag spot weld. So the laser is scanning side to side, penetrating through this first piece into the base material of this tube here, and creating a very robust weld. Just earlier today, I did one of these and a customer asked me to try to hammer this off. And so I took a hammer and it would not break off. So it's very, very robust. Just kind of showing some cool technology and some of the speeds you can achieve using the LightWELD with the Fanuc CRX Go robot.
So Evan, on that one, did you make up a custom setting for the speed for the welding?
Yeah, so I'll bring the tablet over here so I can show you guys. So on the tablet, as Glenn and Brendan were both mentioning, there's a timeline driven teaching mode. So there's these icons and I drag them in order. Each one of these icons I can then adjust the details of, including positional data and some of the welding information, such as the welding program. In these cases, because of this, the weld speed here being higher than your average handheld welding pace, it was necessary to make custom settings in order to create the proper weld. So I made a user setting, and the way I did that is I went into our browser, entered the LightWELD interface. Oops, there we go. This LightWELD interface allows us to select and create, depending on the LightWELD model, between 10 and 20 custom settings where you can take more control over the laser. And this gives you the ability to get deeper penetration into your weld and also have more control with really thin materials. In this case, I used it to create a good weld, even though we were moving faster than average. So it's a really powerful tool, this user interface. And you can just do it right here on the tablet, which is really nice. And then, so then when I call up that setting, all that information is already there. Yeah, so that's how it works. You can see there's some more commands on this timeline. And if you want to adjust any of them, you just click it. It'll bring up the details and you can change the positional data. As well as to touch up a point you can move to. So you can slide this bar here and the robot will actually move to that position. So it just so happens that one's already there. Let's move to this. I'll slide this bar. See how the robot just kind of moves over there. I'm not sure if you'll see it.
Yeah, maybe back
Yep,
out.
there you go. So it's moving there. Yeah, it's been a really nice system to work with. This is my first experience with robots, and it's been a really good one. Fanuc support's great. The LightWELD's a really good system on its own, and combined, it's very, very good. So we can show you another weld now.
Yeah.
You ready, David? Is that one? What's the reach on this, Glenn?
It's 74 inches on the 25 IA. And it's 55 pounds is the payload.
Okay.
And the other model that he's going to show here, the 10 IAL, that has a reach of 55 inches and a payload of 22 pounds. And this other one we're going to show wire feeding.
Another question, are there AWS qualified weld procedures such as structural weldings made D1.1 or some sheet metal procedures such as D9.1? This is Evan talking here again. I cannot speak on those specific ones. I think there'd be some people in here, maybe that would be more qualified to answer that. Glenn knows a little bit about some of the standards that this LightWELD system has met. personally, I don't. So I would, maybe Glenn, if you could speak on that possibly?
Yeah, IPG has tested this to the aerospace standard, AWS 17.1. That's been done. As far as AWS procedures, that's really not something that IPG does, just like it's not something that Lincoln or Miller does. The AWS needs to do that, or the individual members need to do that. So I can't point to some standard other than I know it's met the 17.1 AWS aeronautical standard.
Yeah, the question, Glenn, was
Comes up
also
all the time.
AWS C
Yeah.
7.4. But I think for more of those questions, you might want to reach out to IPG about it. I'm not 100% certain on those. It is a fairly new thing to be doing in a handheld format. So, okay, so let's run the next weld program. I think it's set up right here, very close to us here. Does the camera tilt down that far? Okay, so it looks like we're a little bit limited on our camera angle. This is the weld here. Thank you for the information. Just with the newest of the technology, it'd be nice to know if people are having success, qualified procedures. Okay, thank you. Thank you. Okay, so let me go ahead and run this one. We were working late last night on this one, trying to get a second process going. So it should weld 2 different weldments here. This is an outside corner weld. There is about a quarter overlap on these 2 pieces of 90,000 stainless. And so this is the LightWELD XR using the provided, or actually not the provided wire feeder on this one. This one has a analog control, but it's yeah, so it's feeding a stainless wire 0.45 diameter. And yeah, so been working really well for us so far with our testing. And then we're going to do an inside corner on this one. And when that one's done, I'll take it off of the table and give you a nice close up of that weld. Beautiful. Okay, so David, if you wouldn't mind zooming in on these for me. Go right here. Okay. That's the outside corner one? Okay. All right, so you can see here, really nice, clean inside corner weld on the stainless. Let me get the angle right there. Hopefully you can see that. Yeah, so nice, clean inside corner weld, very nice tight bead. We have very consistent penetration on the back.
And Evan, didn't you say there that on some cases you can actually feed more wire into the joint if you want to fill it?
At the moment, we haven't really done a whole lot of doing that. We did have one outside corner where we overfed the wire to create a bigger buildup.
Yeah.
But for the most part, you want your joint fitment to be as tight as possible. Just to make sure that the consistent the robot wants, you want the parts to be very consistent with this welding. So yeah, so we have the inside corner there, and then here's the outside corner. This one came out really smooth. Gas coverage not quite as nice on the outside corner. Just naturally how it is with you know, the gas just kind of flows, doesn't sit there as well. But still, the weld is very consistent. Try to give you a good visual there. Very consistent, uniform profile throughout, and it filled the bevel there nicely. As I mentioned, this is about a quarter overlap the way this was fit up on this 90,000 stainless. This is the parts before welding. So you can see it has a nice little groove there. But something to keep in mind is, you know, the way we bent these up, they're very consistent. They have tabs locking them into place, and this is really going to help you out when you're welding with the LightWELD with the collaborative robot. Very consistent parts is going to help you out a lot. Okay. Do you have anything else, Glenn?
No, not really. Can you hear questions, Evan, or?
Yeah, let me see if there's any more questions.
Okay,
Let's see. Somebody said, Sarah sent us fillet samples a while back. They passed with flying colors on macro etches and fillet breaks according to D 14.3 and B 2.1. Okay, that's great. I didn't know about that. That's awesome. I have seen some strength tests done, and the LightWELD really excels as far as the strength goes with the weld strength. Any other questions from anybody? Text or audio, doesn't either way. Let's see. Any seam tracking possible yet? So we are currently working on that right now. We have the device. We have a representative from the company who made it coming to our shop in the next few weeks here to help us get it set up and going. But I'm really eager to get that going with it and learning more about it.
and the device that we're testing is from Servo Robot.
Yeah, it's a servo robot device, and we are going to be trying it with the wire feed. We'll probably start with Fusion just to get it going and figure out how it works, and then we'll go to the wire feed next. That's how we've been going through this process of integrating this.
Hey, Brennan, could you elaborate on that at all?
Yeah, I can. So the servo robot product will be a cube that gets mounted up by the torch. We can scan the joint to determine where to start on the joint, but then also if the joint is moving throughout the process. One of the other benefits on that is also going to be your laser touch. So I know Evan just explained it really well. We'll track the joint to see if what's moving, but then also if your part is moving due to upstream processes or things like that, as long as that joint configuration is still tight, we should be able to weld it or at least find that joint. And that product's been around for very long, very well reputation in the market, and is really reliable. So,
And that integrates pretty well with the CRX then, or?
absolutely, that's got some even built-in icons that work with that product to make it easier for your operators to throw in a teaching or searching routine.
So as I could tell you, as far as price wise goes on a retrofit basis, like I said, there's two models. There's the Fanuc CRX 10 IAL. That's $69,750 on a retrofit, and the CRX 25 IA, that's $85,750 on a retrofit basis. If you need any additional information, you can get a hold of me at Serra Laser at info@serralaser.com. I can answer probably pretty much any question, or I'll get in touch. I'll have you get in touch with Evan. Evan's been working with it more than anybody. We have two people that pretty much do this almost on a full-time basis, which is Evan and David. And we'll go from there. Do you have anything else to add? Brennan?
I do not, no, sir.
Great job, Evan and Glenn. Good job, guys.
Okay,
Thank you.
thanks. Thank you very much. And we'll see you later. Oh, if you need a copy of this, let me know too, and I'll send you a copy.
All right. Any more questions? Just reach out to us. Thank you.